This video will cover the basics of formatting strings and numbers in Python version 3. In this Jupyter notebook, we will load the statistics and the pandas libraries. We're going to use statistics to calculate some simple statistics, and we're going to use the pandas library to be able to put data in a series and then do some number crunching on that series. So first, let's store a number in a variable. So we've created a variable and we've loaded a value in it. And when we do this, because we have put print down here, it will print it out. If I remove this and rerun that cell, then nothing prints out. So basically, we need to have a print function so that we can actually print something out. Now, we can also combine literal text with variables. And so here I've said the number is, and I've surrounded this by single quotes. You can use single or double quotes. And then you can separate that with a comma and then put the next element that you want to be printed out through the print statement. So in this case then, this will take this literal text and then append to it the value of this variable. Alright, so let's put my first name and my last name in some variables, and let's start combining some text with a literal string with a textual variables. So this should say my name is Doug, which is my first name. And then we can just say comma last name, and then that will say my name is Doug Dean. So here we've got a literal, and then we have two textual variables. If we want to put an interspersing of these, so in other words, I've got some literal text, a variable, literal text, and another variable, I can do that. Now in this case, what I've done is I've inserted the single quotes inside the double quotes. What that will do is, by using double quotes, anything inside will be shown, and so it will show the apostrophe here. My students tell me that if you're cool in today's world, you're lit, so I'm going to say the lit one, but I know it's kind of tongue-in-cheek, so I'm going to say the lit one and use a single apostrophe. So if I execute this cell, then the name is Doug, my name is Doug, the lit one, Dean. Okay, so because we've used the double quotes on the outside and the single quotes, then it preserved the single quotes on the inside. So let's load some numbers into a simple series. So we're going to load these integers into a series, and we'll call a series ML. So pandas invokes the series method. It creates the series using this and names it ML. So let's take our data that's in this small series. Here are the values in our series, and we can sum them, and we find that the mean is 6. If we take the deviation from the mean, so we take 4 minus 6 and 5 minus 6 and so forth, there's our deviations from the mean. If we square them, there's our square deviations from the mean. We sum them, that's 10. And then if we take the average of that, which we divide 10 by 5, it's going to be 2. So when we calculate variances in data science, we usually just use the n as the denominator when we're calculating it. Statisticians will use n minus 1, and the idea is if you're working with a small set of data, they want to be just a bit conservative, so they'll take n minus 1. Well, if your n is 1,000 or 5,000, the minus 1 is immaterial. And so basically, when I calculate the population variance, I'll just use the n. Since the standard deviation is just the square root of the variance, if we square root this one, it's 1.41, and if we take the sample standard deviation, it would be the square root of 2.5. So in data science, we use n instead of n minus 1. And so let's go calculate those now in our Jupyter notebook. All right, so what I've done is in this notebook, we've got the statistics library that we've named ST. And so now inside that statistics library, there are a number of functions. There's the one to calculate the mean, the one to calculate the population variance, and the population standard deviation. So we'll calculate those now. Now it calculated them, but it did not show up, and so let's show them by using our print function. So now we'll take these variables that have been created, where the numbers have been calculated, and let's show what they mean, or show what the labels are. So I put a label in front of these, and so we have these. Now, right here, it just so happens that our variance is 2, and so maybe we would like to format it so that we can have not as many digits. We don't really need to see 20 digits after the decimal place here. And so an easy way to do that then is by using the print function, we can put our labels in, and then after we put in the variable, we can put in the formatting that shows that we want to have 2 digits after the decimal place. And so let's do that now. And so now we have a variance of 2 and standard deviation, and it's showing that we have just 2 decimals after there, so we're not overwhelmed with lots of information. Let's look at another example. Let's say that we create a series where we have numbers that are floating points that have different number of digits on each side of the decimal. This just has 2, this has many, this has 3, this has 3. And so if we wanted to format these so that we have 3 digits after the decimal point, this would be the way we could do it. So we have a simple for statement in here. It says, so for X in numbers, so that means for all of the items in numbers, we want to print them. So we'll execute this cell now. And so now what it does is it gives us, irrespective of how many digits were in the original series, it just shows us 3 digits after the decimal place. Now, this doesn't line up very well, and so it's a little busy to read. And so to make things line up, we can put the number of digits that we want in the entire sequence of digits and how many are on the right side of the decimal point. We're just going to have a number space of 10 with 3 digits after the decimal place. Let's see how that works. All right, so now over here we have 10, and the first 2 digits are invisible because there was nothing in them. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 3 after the decimal. So it says 10 characters all together, 3 after the decimal place, and it lines them up nice and pretty for us. And of course, if we change this to 2 or to 4, or we could also change this to lesser, or more. So let's just do one where we go, all right, let's make 12 digits and we'll have 4 after. And so you can see now we have more digits over here. And so basically what we're doing here is we are manipulating the space here and making things line up the way we want them to line up. Let's look at another formatting scenario when we're working with numbers. What if we have a really large number? And sometimes it's kind of hard to say, is this millions, is it billions, what is it? And so one thing we can do here is, let me load this into this variable, and then if we put in this for our formatting, what this will do is this will put commas in between the digits. So let's do that. So basically what's going on here is that, put that in, and then if we want to say we just want 2 decimals after, we can say comma dot 2f, and then that will do that. So that is the basics of how to print items in Python version 3.